All right, you guys ready? Okay. So, if we have the function y equals negative 3 x to the 5th plus 5 x to the 4th minus x to the 3rd plus 6x squared minus x plus 1, this is just kind of a long drawn out polynomial function. We looked at some of these when we were doing characteristics of polynomial functions, but to find the degree of a polynomial function, all you have to do is look at the highest exponent. It is often the very first exponent, but not always. So oftentimes they are written in descending order, meaning the biggest exponent would be first, but they are not always written in descending order. So the degree of a polynomial function is the highest exponent. The highest exponent. All right, so next we're going to look at how that degree impacts the general shape of the graph. So linear graphs you guys should be familiar with because you've been dealing with them for a long time. So if we look at like y equals x, that's a straight line, that's a linear graph. This is a positive coefficient, and that just means that it doesn't have a negative number in the front. It would have a positive number in the front, so it would look like this. I could do like 3x plus 1, which is going to shift it a little bit, but overall, or let's do a different number. Let's do like 3x minus 4. It's going to shift it more, but overall it's still going to have that positive slant to it. So we're going to just draw a little sketch of that. This is a linear graph. This is a positive coefficient. Don't turn it in now, just hang on to it until I'm done with notes. Okay? So just work on your assignment. A negative coefficient is going to have the slant going the other way because you have a negative slope in the front. And we kind of talked about that on Friday when we were taking, when we were looking at the graphs as they graphed them, and we were putting our pencils on the arrows, and we were figuring out if the stick figure was walking uphill or walking downhill. That was us figuring out if the graph had a negative coefficient or a positive coefficient. So now we'll just be able to tell from the equation itself. Okay. Next we have quadratics, which are going to be similar to anything with an even exponent. So we have x squared looks like this, but then if I add x to the 4th, you're going to see that x to the 4th also looks like that. It's just a little bit skinnier. And if I add another graph, if I do x to the 6th, you're going to see x to the 6th also looks like that. It's just a little bit skinnier. And if I do x to the 8th, you're going to see x to the 8th also looks like that. It's just a little bit skinnier. So each time I graph another one, all it does is it puts another U-shaped graph kind of in the center, and it just makes like a skinnier, skinnier, skinnier graph. So all of the even exponents, so y equals x squared, x to the 4th, x to the 6th, x to the 8th, any graph that has an even exponent, all of those are going to be these U-shaped graphs. So we are going to deal with not just x squared, but we're actually going to deal with the higher exponents as well. So we might have a graph that is like x to the 10th, or a graph that is like x to the 8th, or x to whatever. So we're going to think of these as even exponent graphs. So as long as the graph has a positive in the front, a positive 2 or a positive 1, as long as it's positive in the front, it's going to make the graph go up like that. Mm-hmm. No, I was just showing you guys that they're all the same. And then as soon as I take one of these and stick a negative in the front, so I'll go ahead and put a negative in front of this one. As soon as I stick a negative in the front, then it's going to make that one go upside down. So the rest of these are still going to be right side up because the rest of those are still positive. So it's just graphing those other ones. But the first one, I had put a negative in the front, so it made that one go upside down. So we're going to say that this first one, this is a positive coefficient. As soon as I stick a negative in the front, and then they go this way, and they have negative coefficients. Okay, and I just want to show you guys that they can kind of do squiggly stuff in the middle. So I could have like x to the 4th plus 3x to the 3rd minus 5x squared plus 3x minus 2, something like that. See, there we go. So overall, you can see that this graph still has that U shape to it. I just kind of made my U like mutated almost, where it's overall it's still a U shape. It's just like this side got pushed in a little bit. All right. So anytime you're going to have your leading exponent or your degree be something to an even power, then it's going to give you that U-shaped graph. This one was positive, that's why the U-shape was going up, but I had added other stuff onto it, and so it warped that U-shaped graph, and it made it kind of weird in the middle, but it still had that U-shape overall. Okay, so let's go ahead and look at the cubic type of graphs. So we're going to type in x to the 3rd, and you can see that it has that kind of, they call it an S curve, so it goes up, it levels off, and it goes up. So let's go ahead and draw a sketch of that. So it goes up, levels off, goes up. That's a cubic graph. And then if we look at the other odd graphs, you'll see that they do variations of the same thing. So if I do x to the 5th, you'll see it does the same thing, but it's a little bit skinnier. So it just got kind of taller, skinnier. If I type in x to the 7th, it does the same thing. It just gets even skinnier as it goes up. So all of the odd graphs, y equals x to the 3rd, x to the 5th, x to the 7th, they all look the same. And this is if you have a positive coefficient. If you have a negative in the front of the graph, all that it does is it makes it go the opposite direction. So once I stick a negative in there, then it's going to go down, level off, and go down. So this is the positive coefficient. There's the negative coefficient. Okay, are we good so far? Good? All right. So for end behavior, we're just talking about the arrows. So we have the evens, which would be like x squared, x to the 4th, x to the 6th. And we have our arrows could be both up, and that's if we have a positive coefficient, or we have that they could both be down, and that is if we have a negative coefficient. And of course, we know that the inside of the graph, it could be like a nice U-shaped graph, but most often it wouldn't be a nice U-shaped graph. It'd probably have some sort of squiggle in the middle. So a lot of people don't kind of put this U-shape in there. They erase the U part in the middle, and they just say that the arrows both go up or both go down. If that feels weird to you, if you want to just say that it's a U-shape, that's fine. Just know that the middle could have some squiggles to it. And then we have the odds. So x to the 3, x to the 5, x to the 7, x to the 9. And we have something like this for a positive coefficient. And then something like this for a negative coefficient. And we know this is just the overall shape because the inside could be squiggles. All right, and we talked about this on Friday. We talked about multiplicity, and multiplicity is just how many times that answer happened when you write the equation. So multiplicity, that word is the number of times that x-intercept shows up in the equation. So if that x-intercept is in the equation once, it's a multiplicity of 1. If that x-intercept shows up twice, it's a multiplicity of 2. If it shows up 3 times, it's a multiplicity of 3. So in our class, we only deal with 1, 2, and 3, but technically you could do any number. You could have a multiplicity of 7. It would just look a lot like a 3. You could have a multiplicity of 6. It would just look a lot like a 4. It would just be like a skinnier, or sorry, it would look a lot like a 2. It would just be a skinnier 2. And then we talked about multiplicity on Friday because you guys were doing it when you were looking at recognizing the equation of the graphs. And if you guys remember the multiplicity of 1, it just goes straight through the x-intercept. So multiplicity of 1 is just straight through the x-intercept. We said a multiplicity of 2, we said it bounces at the x-intercept. And then for the multiplicity of 3, we said that it kind of squiggles through the x-intercept. So down, level out, go down, up, level out, go up, down, level out, go down. Okay, so go ahead and flip over to the back. We're going to draw some of these. So the first thing we want to do is figure out what our degree is. And we find the degree just by counting up the exponents. So anytime you don't see an exponent, you're just going to count that as a 1. So this is 1, 2, 3, 4, 5, 6. So this would be a degree of 6. It's a positive in the front. So this is an even number. It's an even number with a positive in the front. So overall, I know that both of my arrows are going to go up. Does that make sense? Overall, they're both going to go up. So I can see that I have 3 x-intercepts. I have an x-intercept at 0, positive 3, and negative 5. 0, positive 3, and negative 5. I can see that the x-intercept at 0 has a multiplicity of 1. So I usually just write M1. That's me doing shorthand for multiplicity. I can see the x-intercept at 3 has a multiplicity of 2. And I can see that the x-intercept at negative 5 has a multiplicity of 3. So what I'm going to do next is I'm going to draw them. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Got 3. Got 0. I can see that both of my arrows are supposed to go up. So the first one that I'm going to draw is at negative 5 right here. And I have 2 options for a multiplicity of 3. I can go up, level off, and go up. That's one option. Or I can go down, level off, go down. Which one makes the most sense to connect to my arrow? Is it go up, level off, go up? Or go down, level off, go down? Yeah, the go down one makes more sense for my arrow. So there's my first one. I'm going to say there's my negative 5. Okay. Then for 0, I have a multiplicity of 1. And these ones are usually pretty easy because you're just going to go like straight through. But you can always do kind of a slant with it. So I always say you can do a positive slant with your straight lines. Or you can do a negative slant with your straight lines. So which one makes more sense? Should we do the positive slant? Or should we do the negative slant? Which one makes more sense? The positive slant makes more sense. Okay, so now I'm going to say the positive slant. And whenever we connect the 2 answers together, we can't connect like this because polynomials don't look like that. They don't have sharp corners. They always have curves. So we always make sure that when we connect them, we have a curve that's connecting one piece to the next piece. Okay? And then for 3, it says multiplicity of 2, so we have 2 options. We can have a positive U-shape, right, like a U-shape on top of the x-axis, or we can have a U-shape on the bottom of the x-axis. Which one makes more sense for the blue and for the arrow? On top. So there's my U-shape and my arrow, and then I just make sure that I connect it, keep it from looking weird. Okay. So blue was my 0, and then that was green. Okay. Let's try the next one. This one, the degree is going to be 2 and 1. So what's the degree of this one? 2 and 1 is? 2 and 1 is? 3. It's got a negative in the front, so this is an odd number. It's got a negative in the front, so overall it's going to be something like this. We have 2 x-intercepts. We have an x-intercept at 0 and -5. 0 has a multiplicity of 2. -5 has a multiplicity of 1. Every single Chromebook should be put away. This is a no calculator activity. So everybody fold the Chromebooks, fold the laptops, put them away. All gone. So Christian put it away, Isaiah put it away, Talana put it away. No Chromebooks today. All the Chromebooks are gone. We don't need them. Put it away. All right, so we've got first arrow going up. This arrow is going down. At -5, we have a multiplicity of 1. So do we want a positive slant or do we want a negative slant? We want a negative slant. That's what makes more sense. Okay. At 0, we have a multiplicity of 2. Should we have a U shape going up or a U shape going down? We should have a U shape going down. Okay. And then we just have to connect them together. Okay, what's the degree for number 3? Four. And that's an even number. It's positive in the front. So overall it's going to be like this. What are the x-intercepts? -3 and 4. -3 and 4. Up arrow, up arrow. They both have a multiplicity of 2. So for -3, we can have a multiplicity of 2 like this or like this. Which one makes more sense? Yeah, it should be up. So the U should be above the x-axis. Okay. And then for 4, we have a multiplicity of 2, so we're going to have the same 2 options. The U can be above the x-axis or below. So which one makes more sense? Above. And then we just have to make sure that when we connect these, we do it with a curve. What's the degree for number 4? 5. Okay, that's an odd number. We have a negative in the front. We have 2 x-intercepts. What are the x-intercepts? Zero and 7. Zero has a multiplicity of 3. 7 has a multiplicity of 2. Up arrow, then down arrow. So for 0 with the multiplicity of 3, we can go up, level off, go up, or we can go down, level off, go down. Which one makes more sense? Go down? Okay, so we're going to go down, level off, go down. And then for 7, we have a multiplicity of 2. And so which one should we do for our multiplicity of 2? We should go down. Okay. All right, do you guys want to keep doing examples, or do you feel like you've got it? What do you think? Feeling okay? Need another one? Okay. Do we want to do 5 or 6? 5? Okay. So if we write the exponents that are missing, anytime we're missing an exponent, that's a 1. So the degree for 5, we have 1, 2, 3, 4, 5, 6. So we got a degree of 6. That's even. It has a negative in the front. So that's going to be an upside down U. So the arrows are both going to go down. And then we have 4 different numbers for our x-intercepts. And you guys see what they are? -5, -1, 2, 5,